which is security. Not many of us spend time and energy and effort thinking about how important mobile security is in our day-to-day lives. But in fact, when we talk about things like money, when we talk about things like payments, security is more important now than it is ever. So I'd like to introduce onto stage Stephen Sprague, who is going to be talking to us about mobile cybersecurity, the power of blockchain, and trusted computing. Stephen.
Thank you, everybody. I really enjoyed that last panel. To the extent you can enjoy conversations about open banking, it's almost as hard as trying to make security entertaining in the middle of the day before lunch. But we'll give it a try. So here's the challenge. I mean, what an incredible setup. They actually think the security problem is a headache for the user. That's because the banks haven't given us digital identity and they haven't given us e-commerce. Like, what's e-commerce? That's where you type your credit card number in and then you flip it over and you type the 3 numbers in on the back because, no, that's not what we want. We want something simpler. So we've been hearing about 5G and the 4th Industrial Revolution and it's going to change the world, right? Last night, because I just flew in, right? You're at 3 o'clock in the morning, you're watching the MWC channel. This is good news to sleep to. But it was great. I mean, Verizon talking about, the currencies of 5G. It's about the user. The fundamental shift that's going on is the old model was a network service surrounded by users. The new model is a consumer surrounded by services. How many people have more than one app on their phone? Everybody. Great. Everybody uses the same password, right? Yeah, you're not supposed to. You're supposed to type different ones in for every app. Have you wandered around this place? There's 1,000 booths out there that are all telling us that they're going to give us another key. So this is the problem. There are too many keys. Like, you're going to have keys for the hot tub, keys to turn off the dishwasher, keys to start the Ferrari, right? Keys for your drone that follows you around, taking pictures of you, live broadcasting on social media. You're going to need a key for that also, right? Where are you going to put all these? That identity information, that infrastructure of keys is a challenge for us. The result is a terrible user experience. What's your favorite form of multi-factor authentication? Everybody has one. Just in your head, imagine the one you think is your favorite. You're wrong. Your favorite form of multi-factor authentication is the send button. You dial the number and push send. Now take any stupid scheme that we've all been trying to convince you of that says, no, let's get rid of the send button. What we're going to do is dial the number, and then you wait for your second factor 6-digit code to show up. Then you type that in, and you connect the phone call. No, we got rid of that in 1994 in America. We copied this GSMA crazy stuff, and we put chips in every phone, and fraud went to 0. What? You mean somebody actually solved the cybersecurity problem once? Yep, we had 80 million cloned identities in the US in cell phone industry in the mid-1990s. They put a SIM chip in every phone, and fraud went to 0. We know how to solve this. We need to re-engage the device in the process. And so fundamentally, we're starting to experience this at scale. Like, the fake data thing on Facebook's a little entertaining from a political perspective, but really the challenge is, how do you know any of the data is real? How do you know anytime you look at the screen, the data wasn't written by a bot? You don't. And that's a challenge. It's a challenge in financial transactions, in IoT, in running the world. We're going to hook life systems to data. Like the other day, somebody was asking, can we hook your mobile phone to your pacemaker? I'm like, oh my God, what a tremendous, they're doing it. It's like, ugh. You don't have a usable digital identity. It's a problem. It runs you into a problem every single day. Like the other day, they just installed parking meters outside my wife's favorite restaurant. Fantastic. So now you go fill in the app, you download the app, you fill in your credit card data. They need to know my address to park. Why? I'm parking. They asked for the license plate on my car, so they clearly know who I am. They don't really need to know anything else. Then I've typed in all my stupid credit card information. Then the app proudly announces it costs 50 cents an hour to park, and there's a 20-cent convenience fee. What? That's a 40% transaction fee, and it took me 5 minutes to do the transaction. You're telling me after 20 years, like how many years we've been coming to this conference, and we still don't have money in a phone? That I could spend 50 cents for parking? Really? Globally? How much time are we wasting? Like 3 billion people with mobile phones wasting 15 minutes a week on filling in forms because nobody has a digital identity or secure e-commerce. So what's the solution? The solution is interesting. We've been playing around with trying to light up and turn on the global platform, trusted execution, SIM, et cetera capabilities we've all been talking about in the industry for a long time, and then marrying that to blockchain. Why? Because we don't have to talk to the banks. We can finally build you secure e-commerce. That's what a hardware wallet is. What you see is what you sign. Proper collection of user consent, a PIN number or a biometric to release the key for a transaction. Hardware protection of a key within the device for the assurance that the key is only used when it's authorized to be used. Do you know how you know this? Because it's the point of sale terminal everywhere you shop in Europe. Stuff a smart card in a box, you get an image on a screen in a Genico terminal, it tells you what you see is what you sign, and then you have to type in a PIN number. I'm an American, we don't type in PIN numbers. They forgot that entire leg of security for 300 million people in the US. Really? Like, we sign things. Nobody checks the signature. So it's about bringing all these pieces together. You have payment, identity, information assurance, and compliance is a new protocol. So when you look at blockchain, everybody's like scratching their head. Why blockchain? Is it ever going to happen? Is it ever going to work? Embedded in the protocol is identity. When I send you 10 cents with Bitcoin, I also exchanged a public-private key. I opened an account with you with no additional action. It's an amazingly more efficient mechanism. Now, it's still early on. It's still clunky and cumbersome and hard. And we'll work on those pieces. And pieces will become more centralized and other pieces will become more decentralized. But what's important is payment, identity, information assurance, because now we've exchanged keys. I can send you a secure message. And I can automate compliance as part of the transaction. Recently, we did a transaction with the R&D group at Telefonica. And what we've developed is a dual root of trust capability, because we don't want to trust with just a single entity. We actually want to trust the infrastructure of more than one supply chain for security. So we've built a mechanism that combines the trusted execution environment and the SIM. We use the SIM to additionally protect the private key. This brings us carrier controls and protection of the key. It also gives the carrier a job. And so now I can give you a blockchain wallet where you call your carrier and turn off all the keys. So if I lose my phone, I don't lose all my keys. I didn't delete them, I just locked them up. So when the Uber comes back with my phone, I can get all my keys back. So it's just giving the carrier a real job to help us in delivering real identity and real e-commerce. I'm just going to ask a question. There's a clock here somewhere that tells me how much time I have, but I don't know where it is. So we'll be careful. So as part of that CLIP project, what we've done is we've combined a trusted execution environment, the SIM, and then on top of that, Rivetz has built a platform and a collection of APIs that allow any third-party application developer to take advantage. I don't care whether you're building an app for entertainment and gameplay or trying to build for banking. We all have the same problem. We want to improve the quality and value of the subscriber relationship. The greater we make the security, the simpler the experience. There's so many applications where you don't need a password. You just need a registered device. The beauty of a registered device is I'm only asking the human to do one thing. Notice if they lost their phone. Have you ever tried to remove a phone from a 14-year-old? It's a fantastic experience. You get it like a meter away, and you can like lose the rest of your afternoon, right? It's not so simple. So we're incredibly aware of things. On the other hand, how many of people know that their passport details were all ripped off because Marriott lost 500,000 people's passports? Like, when are you going to find out? Well, when your passport's compromised. Like, what is that? So it's an interesting challenge today. We have no awareness of when we lose our password, but we do know when we lose our device. So have my device be a good little robot, log me into all the things it's supposed to log me into, choose really hard credentials and keys, and then just ask me to keep track of my device. Now, what we've tried to do is to enable things like enterprise policy. So I can take that key and I can add policy to it in the device. I can add controls. I can have my device when it makes new keys for wallets at 3:30 in the morning at the bar because I ran into somebody like, hey, you should try this new crypto. Make a wallet. This is never a good idea. Your device should automatically talk to all your other things and back up your keys. Because your superphone is not your center of gravity. At the end of the day, your collection of devices is your identity. Leverage your TV, your car, mom's phone. That's kind of an interesting idea. I mean, mom as a backup and recovery mechanism is fantastic. None of us call our mom nearly enough. So we've implemented here a few different applications that sit on top of this platform, and we're showing them here at the show. So I'll take you through each one of them. WAN chain, very cool application in the blockchain space. They make it possible for us to move tokens back and forth, enabling chains to share data and value within the application itself. So I don't have enough of these tokens. I have plenty of those. I can just swap them out in-app. It simplifies the user experience. It allows the consumer to operate multiple applications and always have the right tokens that they need. And we can automate that process within the device. And it delivers a new model of privacy in those transactions because I didn't have to go to a central authority and buy my coins. I can kind of move from one to the other to the next. So it's an interesting example of microtransactions and managing some of these new toys in tokens and the economics of new applications, whether it's gameplay or professional applications, having the right token at the right time is going to become important. Civic builds a fantastic blockchain-based attribute identity. How do you get verified once and reuse those attributes? How do I know that the attribute that was certified by this service can be replayed and reused? It provides an ecosystem that really allows us to abandon the password. Because what I have is the beginning of a real digital identity. Not only the attributes verified by third parties, provably verified by third parties, but then the security necessary around the assertion of that identity in the keys in the device so that I can absolutely assert that that key is connected to my device and to me. And so we ultimately help create a world where the people can control and protect their digital identities. It's about transferring control to the user. One of the interesting things about blockchain is people talk about blockchain as like nobody's in charge, it's just running on the internet. I disagree. There's one central authority for all of blockchain. Who's the central authority for all of blockchain? The owner of the private key. Blockchains do nothing if you don't send them instructions. They're just a clock. They'll just go mine another block. If not a single person sends an instruction, the blockchain does nothing. It just counts, adds another block. And so this is the ultimate shift of control to the user. So PeerStream is an interesting application in messaging. They provide a routing protocol as well as provide encryption of individual messages, both for simple messages and streaming video. So this provides end-to-end encryption on an identity you control. You don't have to have a central account. I can just establish a friend relationship with you, and you and I can connect and converse, and you can have a very high level of assertion that when you get another message from me, it actually came from me. As we bring the security of what Rivetz is providing in this ecosystem, we can now assure that that message came from a known device in a known condition with known controls. If you had to think about policy in your organization or any other organization you belong to, or you want to think about writing government policy, it's simple. It's actually very simple. Only known devices connected to sensitive networks and data. We don't do that. Barcelona is run on unknown compute with known users. Think about that for a second. So all the current life systems that support the entire citizenry of Barcelona runs on unknown compute. How can I say that? Because they run PCs. I was heavily involved and spent hundreds of millions of dollars in the 2000s timeframe in putting BIOS integrity into the PCs, and then no one turned it on. So when you boot your laptop, you have no idea if the BIOS that runs your laptop hasn't been tinkered with. And if you want to read the effects of tinkering with the BIOS, go read the Wired magazine on Maersk, where they lost their entire network, and it cost them $10 billion in a week. They lost the whole thing. They had no idea where any of the containers were, any of the things were, who went where. It was fantastic. And they got lucky putting it back together. They actually had a power outage somewhere in Africa that allowed them to recover the database because there was one copy remaining that was offline. So this is about putting the subscriber in control. So when you listen to 5G, we're going to connect everything. I don't really care. We're going to use Wi-Fi, fiber, wires, multiple providers. It doesn't matter anymore. What's important is that we help the subscriber connect. That it's a network of customers and services. The method of connection is not important. Mobile is about a shift from ports and passwords delivering service to services being delivered based on the identity of the device. The user is an attribute. IoT, the difference between IoT and mobile is that mobile is a device identity network with connections as a primary protocol. IoT is a device identity network with messaging as a primary protocol. So mobile's connections, IoT is messages. There are no routers in IoT. There are no gateways in IoT, properly done. That just means the reason you need a gateway is because the device is too stupid to be able to form an encrypted message. That way I know only known sensors produce data. So keys on a blockchain, fantastic place to start and put them. Nobody runs it. It's a great place for me to have my root keys for my collection of devices. Backup and recovery is a critical service. We need to build these systems so we as consumers never lose our keys, ever. It's not complicated to build. We do have to trust some entities in that partnership. Maybe we should shard our keys, put a third of them in Russia, a third of them in the European Union, and a third of them in America. Pick your countries of choice. You know, as long as it requires the UN Security Council to recover your keys, we're probably okay. Like, that's an adequately dysfunctional body to keep us all safe. And we have to embed commerce within the user's device to protect privacy. Like, build it in. Security is not an add-on. It has to be built in from the foundation. We've spent years at GSMA talking about embedded security in devices. Why is it not turned on? Because the banks wouldn't turn it on. We just passed PSD2 to get the whip out to whip the banks to turn it on. They still haven't turned it on. How do I know this? I shipped 160 million copies of software with Dell, Acer, Asus, Samsung, and Intel, putting a chip on the motherboard of every single one of your PCs. And we wanted to do 3D Secure in 2007. What? You mean tamper-resistant multifunction security embedded in the PC for a non-clonable identity for Visa 3D Secure invisibly embedded in every box and they wouldn't turn it on? You know why? Visa makes 4% on internet transactions and 1% on face-to-face. If we solve the security problem, we reduce their revenue by 75%. That's why. So don't trust the banks. The banks aren't on your friends on this. They're making money on the fraud. This is about bringing the next generation of identity and e-commerce to everyone. We're finally getting some of the systems. Blockchain's an interesting piece. Open banking is a fantastic piece of this puzzle. But IoT is the same problem. An IoT message, sending a message to the light switch to turn on, is exactly the same as sending $100 million from point A to point B. It's exactly the same thing. And we could argue in some places it might even be more important, like turn the stadium lights on when there are 100,000 people in the stadium. Turns out to be a relatively important little transaction on your little smartphone. So I think I'm out of time, which is good because I'm at the last slide. Our booth is right out there. If there's anybody who has any questions, we'd love to show it to you working. Thank you very much.